The other thing I want to talk about here is the a more official definition of what we're talking about, which is talking about how things are done. So it says customer routes are learned via an OSPF adjacency with the customer CPE router. That CPE stands for customer premise equipment. These routes are stored in a VRF instance. Company A and Company B in our case are the two separate VRF instances that we created. So Company A and Company B have routes stored in their own instance. Each VRF instance has a route target and a route distinguisher. Route distinguishers are used to keep track of where the routes came from and usually take the form of the loopback of the router that originated them, colon, the customer number. Now when I sign a contract with a customer as an ISP, I'm going to assign them a unique number. This number is what I'm going to use where after the loopback of the router that originated the connection. An example would be a route distinguisher of 2222 if the loopback for router 2 was the one that initiated it, and the route target would be 1 for the first customer, where 222 is the provider edge loopback and 1 is the ID, the unique ID number assigned to the client. So that's important. The route target is usually in the form of the ASN number, or the ASN number of the BGP peer, the BGP instance basically. So let's say that you're running autonomous system 65,000. So your ASN, your 65,000 autonomous number, colon, customer ID. You notice the customer ID here is the same as the customer ID in the route distinguisher. That's a unique number that identifies that customer. Now what happens is that you can set a route target. We're doing both here in this command that you see, but you could set it for either inbound or outbound. The route target command creates a list of import and export route target extended communities for the specified VRF. Learned routes that carry a specific route target extended community are imported into all VRFs configured with that extended community as an import route target. Routes learned from a VRF site, for example by BGP, RIP, or static route configuration, are contain export route targets for extended communities configured for the VRF added as route attributes to control the VRFs into which the routes is imported. The VRF will basically only accept routes into the routing table that have the correct extended community. That's all that's saying. It's a rather kind of roundabout way of saying it. It's a little confusing. This is why most people have issues with MPLS, because the definitions are a little wonky, especially with all the different terms, which I'm not going to weigh you down with any of that. We're going to get right into the configuration like always with us so that you can really see what you're getting at. So I have this system set up here, as you can see, in GNS, which is a Dynamips GUI. And we are going to take a look. So let's take a look at the ISP router 2, which is a core router. Let's go into the console here. And you'll see ISPR2 as I go into enable mode. First thing I want to do is show you the interfaces. Typo, sorry about that, guys. So we basically have on this router, let me move it down so that you can actually see the router. So you see ISPR2 is the center one here, and it's got 4 fast Ethernet interfaces connecting to other routers in the backbone and the provider edge routers. What I did for the sake of this demonstration was assigned all private addresses. This router also has a loopback address of 2222. So if we do a show run on the whole configuration, you're going to see that we got our loopback interface. You'll see that fast Ethernet 00. We have a network assigned 252. It's a /30. Only 2 addresses. And you'll see that there's a command in there in each of these, MPLS IP. That is the only command required to turn on MPLS. That's it. That's about as simple as it gets. We have an OSPF running, which basically says add all networks on this router. So that way we can, basically we don't have to do redistribute connected. That pretty much does it for us. You know, it's a little bit cleaner way. I don't like redistributing connected routes. I find that it's not a best practice. So when I have another option, I tend to choose it. And I wouldn't do something as in the real world as untargeted as redistribute everything, but for this purpose, I did it to prove a point, and the point is that uh, that this router will never see any customer routes. So if I do a show IP route, let's do show IP OSPF neighbors, so you can see that it's got peers with everybody. 1.1 is this one here. 3.3 is over here, and then the PE routers are 4 and 5, which are the perimeter edge routers. So you'll see it has an OSPF adjacency with everybody. If I do a show IP route, you will see that it knows about all the loopbacks via OSPF. It knows about all its connected networks. And it's got a couple other networks, like between the networks between router 1 and router 4, and the networks between router 5 and router 3, which are not directly attached. It learned through OSPF. You can see that there's no customer routes here at all. Zero, zip, none. So that's important to note. Let's minimize this. Let's take a look at one of the other routers here. Oh, the other thing I want to do before I do that is I want to show you some of the MPLS stuff. So we're going to do show MPLS forwarding table, so you can get a look at what the labels look like. And you'll see that it has a list of local tags that it assigns to these networks. See how it depends on the routing table? It gets these prefixes from the routing table, then it assigns tags. So even though it's a layer 2.5 protocol, it really needs this to be in place for it to work. And you'll see that it's telling you what it's going to do to the outgoing packet. It's going to pop means you're removing the tag, and tag means you're tagging it with some, you're tagging the packet, either changing the tag or doing something. And you'll see that it's popping and tagging a lot of it's popping the tag on almost all of these. It's removing the tag. And the reason why this is removing the tags is because MPLS has something called PHP, or penultimate hop popping. And what penultimate means is the router before last. So if these customers down here are speaking, are sending the packets to their provider edge routers, this router is tagging the packets and sending them out. These customer CPE equipment routers do not speak MPLS, so you can't send them a tagged packet because it's not going to work. So this router has to remove the tag before it sends it down this link. Well, what happens is that these routers can quickly become overwhelmed because they're removing tags and tagging and doing a whole bunch of other work because they're talking to the end users. So what penultimate hop popping means is that if this is the last destination in the MPLS network, the penultimate means before last. So the router before last, in this case this one, is going to pop the tag and remove the tag. So the packet actually transits this link here untagged. This router, ISP1, would do the same thing for all packets destined for R4, and ISP router 3 would do the same for all packets destined for R5. And that includes all customer packets because, again, this R5 is the last hop on the MPLS network. Now you'll see if I go to like router 3 that it's still going to have a lot of pop tags, but it's going to have less than the other one did. Excuse me here, because it's very easy to click multiple windows here and it causes an issue. Here we go. So if I do show MPLS forwarding, you will see here that, like here, this is tag 17. We're changing the tag to 16 before we send it out. So you'll see that because some packets are destined for router 2, which is the middle router, and let's move this down a little bit, because some packets here are destined for here or destined for all the way over here, there are a couple where it does not pop the tag. There's two actually, right? 17 to 16 and 22 to 20 and 21 to 17. So there's three, right? So any packets destined for 4444, which is all the way down here, this is not going to pop the tag because it's not the router before last, right? All the packets are going to go here, and then if this router sends it directly, it pops the tag. But if this router sends it over here, then this router pops the tag. So that's basically penultimate hop popping. So if someone asks you some crazy questions about that's all it means. It's just a way of alleviating load on the provider edge routers. Now you can disable that, but that's a topic for another time. And if I do show IP route here, you'll see it's the same thing. It knows about all the loopbacks, it knows about all the networks. But you'll notice that there are no customer routes in there at all, and there is no BGP process running either.